today we're going to be talking about 5.4. And so we have three sections left. We have three sections left in chapter 5. 5.4, and which is kind of difficult, kind of brings together some of the other lessons that we've had in chapter 5. 5.5 and 5.7. 5.7 is a very short lesson, so we're getting close to the end. 5.5 is not quite as difficult as 5.4, which is what we're talking about today. So today we're going to find the least common multiple of all the denominators of all the rational expressions within the complex rational expression. That sounds complicated. We're going to multiply by 1 using the least common multiple, and if possible, we're going to simplify these. So the whole goal of what we're doing today in chapter 5.4, section 4, is to reduce these fractions. So if I start off with, this is the example they've got. If I start off with this is the fraction that, this is our problem right here. And what they're saying to us is reduce this. Like, we don't want this fraction to be so overwhelming. So it says find the least common multiple of all the denominators. So that's the first thing you need to do. And right now, the denominators that I can see are, well, the 4 doesn't have a denominator under it, but the 2x is a denominator. The x and the x squared are all denominators. So it said, and we did this in the last class, we talked about how do you find the least common multiple of 2x and x squared. So I just rewrote those 3 down. Well, these two don't have any numbers in front of them. So this is really just a 1x and a 1x squared. So the only number I have to worry about is 2. So when I do my least common multiple, I for sure want to list that 2. Then I want to compare my x's. This is x to the first. This is also x to the first, and this is x squared. So my least common multiple is the one that's listed the most. So we would make that be 2x squared. Okay, so if you look at this, what they've done is they've taken it and they've rewritten it right here. Then they multiplied by the least common multiple over the least common multiple. So 2x squared over 2x squared, because this is the same as multiplying by 1. The goal is that they're able to reduce it this way. So they're multiplying by 2x squared over 2x squared in hopes that they're going to be able to reduce this. Okay, so they've taken every single thing and multiplied it by 2x squared. So they did 2x squared times 4 and got 4 times 2x squared. Then they did 2x squared times negative 1 over 2x. And that's how they're getting negative 1 over 2x times 2x squared. They went to the bottom and said 2x squared times 4 over x, which is what this is. Then they had to do 2x squared times this term, 2x squared times 1 over x squared. So that's how they came up. They've distributed that 2x squared and multiplied it by every single thing. Okay, now we're going to simplify anything that we can. So they multiplied these two things together. 4 times 2x squared, well, that's 8x squared. Okay. Then they've got their minus 1 times 2x squared. Well, let's look at this whole thing right here. That would, 2x squared would have ended up on the top because 1 times 2x squared is just 2x squared. And then on the bottom, we would have 2x. Well, the 2's cancel out. I've got x squared over x, which means that this x is going to take away one of these x's, and that's going to leave me with just x to the first power, which is why they have their answer here, minus x, because all of that stuff canceled out and they were just left with minus x to the first power. When they multiplied these two together, they did 4 times 2x squared. Well, that was 8x squared. And then on the bottom, we just have x. Well, one of these x's, this is x to the first, will take away one of these x squared. So I would end up with just 8x, which is how they've gotten that answer. Then they took this one. So 1 times 2x squared would give me 2x squared on the top. And on the bottom, I would have x squared. Well, these x squareds are going to cancel out, and I just would end up with 2, which is what they've got there, plus 2 right here. Then the last thing they did was they reduced it to see if they could simplify it any further. So they noticed that there was an x in both of these terms. So they pulled the x out front. They factored it out. On the bottom, they noticed that there was a 2 in both of these terms. So they pulled the 2 out front and factored that out. So it's kind of complicated. There's a lot of steps here. When the next one that we work by ourselves, I'm going to go really slow, make sure that I hit all of the steps that you need to do. Okay. So this one, they're going to start off kind of easy. It's not as complicated as the last one we did. First off, we don't even have any variables in this one. So what they're asking us to do in this one would be really easy because we're really just dividing on this. I'm going to follow the steps that they use so that maybe that will help, because there's probably an easier way to work this problem, but I'm just going to try to stay consistent. So I'm looking at my denominators here, 3 and 7, and I want to find the least common multiple of those. Well, 3 is prime and 7 is also prime. So I can't factor those out like we did the other day. I just have to multiply those together. 3 times 7 is going to get me 21. So my least common multiple is going to be 21. Just rewriting down the problem. Okay, just writing the problem down again. And remember that whatever our least common multiple is, that's what you're supposed to multiply everything by. So 21 over 21. Okay, and what that's going to do is we're going to say 21 times 2 over 3 and 21 times 2 over 7. We're taking and multiplying that 21 by both of the terms. Okay, when we do that, we're going to get 21 times 2, which is 42 over 3. And on the bottom, we would get 21 times 2, still 42, but this time it's over 7. And then we're going to say, can we reduce this? Well, 42 divided by 3, yeah, 42 divided by 3 comes out to be, what, 14, I think? I'm going to check that in just a minute. And 42 divided by 7 is 6. So yeah, we absolutely could reduce that. And I think we can reduce that even further because I'm noticing that both of those can be divided by 2. So we could reduce that fraction even further. So if I divide by 2, divide this by 2, that's going to get me 7 over 3. Okay, so this whole thing is really just 7 over 3. Okay, we reduced it down. So that was kind of an easier first step. Look at your denominators, find the least common multiple of them. Then you want to take and multiply your fraction by that least common multiple over itself. then you're going to reduce the fraction. Man, when I look at this second one, I've got lots of things that are denominators here. I've got a 4 and a 5 and a 2 and a 5. So I need to look at those numbers, 4 and 5 and 2, and I don't have to list the 5 again. It's already been listed. So that I need to find the least common multiple of those numbers. 4 is not prime. It is, right? 4 needs to be listed as 2 times, let me just rewrite this because so 4 is 2 times 2. 5, not 5. 4 is 2 times 2. 5 is already prime. 2 is already prime. So when you're doing the least common multiple, remember that you want to list the number the most amount of times it's listed in any group. So if I've got 4, I want to list both of the 2's for that. That took care of this, both of these 2's, and it took care of this 2. You compare the list and you list it the most amount of times it is in any list. So I've got to also list the 5 here. 2 times 2 times 5 is 20. So the smallest number that 4 and 5 and 2 will all go into is 20. That was the first thing, is we need to find the least common multiple. The next thing you want to do is take and rewrite your original statement. And you want to multiply that by the common denominator, or the least common multiple, over itself. So we're going to take every single one of these terms and multiply it by 20. Okay, that's going to get me 3/4 times 20. These are supposed to be pluses, sorry. I copied that down wrong. Plus 2/5 times 20 over 1/2 times 20 plus 3/5 times 20. Okay. Well, 3 times 20, right? 3 times 20 is going to get me 60 over 4. Plus 2 times 20 is going to get me 40 over 5. 1/2 times 20, that's 20 over 2. And then on the last one, we've got 60 over 5. Then what we want to do is we want to take each one of those terms and reduce it. Well, 60 over 4 is just 15. 60 divided by 4 is just 15. 40 divided by 5, that's 8. 20 divided by 2, 10. 60 divided by 5, 12. Okay, so then. Okay, so now we want to add the 15 and the 8. That's going to get us 23. And 10 and 12 gets us 22. And then that is reduced. So that would be our final answer, 23 over 22. So all of this stuff up here just reduced down to 23 over 22. And we're going to list our denominator. So I've got 2x to the third. I've got an x squared. So I'm just looking at my denominators here. I've got a 6x. And I've got another x squared, but I've already listed that, so I don't have to list it again. So what you want to do is make sure you're listing your number in front as a prime number. So that 2 is already prime. So we can just say 2x to the third. 6 is really 2 times 3. So I'm going to separate that out so I can make sure that when I find my least common multiple, I'm actually getting all of it. So we want to start out with our numbers first. So I'm looking at 2. This would be a 1 here in front of the x squared. And then I've got a 2 and a 3. I have to list both the 2 and the 3 because they're listed here. So if it's listed any times, you've got to list it the most amount of times it's listed anywhere. So I've got 1, 2 in both of these groups. So I'm just going to list 1, 2. But I've also got this 3 I have to worry about. I have to list it. Then I'm going to decide, well, which x is the biggest? X to the third, x squared, or just regular x? Well, the biggest one is going to be x to the third. So that means my least common multiple is 6x to the third. That is what I'm going to have to multiply by. So I'm going to put 3 over 2x to the third, just rewriting what I had, 4 over x squared, 5 over 6x minus 1 over x squared. And I'm supposed to multiply all of that by my least common multiple over itself. Okay. So that means I've got to take this and multiply it by every single one of these terms. So 3 over 2x to the third times 6x to the third plus 4 over x squared times 6x to the third. 5 over 6x times 6x to the third. 1 over x squared times 6x to the third. Okay, so then 3 times 6 is going to get me 18. So on the top of this, I've got 18x to the third. On the bottom, I still have that 2x to the third. A lot of you guys could probably go ahead and reduce in this step. I'm just trying to make sure I take it one step at a time. I'm going to reduce. I'm going to make sure I am going slow. And if you can reduce it here, in other words, you went ahead and canceled everything out, that's perfectly fine to do that. 4 times 6, 24x to the third over x squared. 5 times 6x to the third, that's going to be 30x to the third over 6x. And then 1x squared times 6x to the third is going to be 6x to the third over x squared. So we're very close now. And here's what I mean by that. So 18 divided by 2, that fraction just goes away. That's just 9, right? 18 divided by 2 is 9. X to the third over x to the third, those cancel out. Plus 24, I don't have anything on the bottom to cancel out with that, but x squared over x to the third, these two x's take away 2 of these x to the thirds, right? So if I have x to the third and I took 2 of them out, I just have x to the first. 30 divided by 6, well, that's 5. And I've got an x to the third on the top, and on the bottom, I just have x to the first. Well, this x to the first is going to take away one of these x to the third. So I would end up with x squared. Okay, minus 6. Well, x squared over x, 2 of these is going to take away one of those, and I would just end up with an x. Now, you want to look at the numerator and the denominator to see if you can pull anything else out of that. So I'm looking at 9 and 24, and I think 3 goes into both of those. I can't pull out any x's because there's not any x's there, but I can take a 3 out. And if I take a 3 out of that, that's going to leave me with 3. 9 divided by 3 is 3. 24 divided by 3 would give me 6. And then I have my x. And on the bottom, I could take an x out of both of those terms, and that would leave me with 5x minus 6 if I pull an x out of both of those. And this is this is complicated. So it's taking all of those steps that you kind of learned before and putting them together in chapter 5. So if you have not watched the videos or done any chapter 5 homework, you want to tackle that first before you try to do all this, because that'll kind of take it a little bit slower. Okay. First step here. We are going to look at all of the denominators. So I've got an am to the 4th, a 2a squared, an am squared, and an a. So these are the things that I'm having to come up with the least common multiple for. Okay, these are the things I've got to come up with the least common multiple for. And I'm noticing that there's only one number up there, and that's 2. So I'm going to go ahead and list it. Then I'm going to decide, well, what's the biggest a I have? And it looks like it's a squared because all the rest of them are just a to the first. So always list the biggest one you have. And then I'm going to look at my m's, and the biggest m that I have is the m to the 4th compared to my m squared. So I would list m to the 4th. Okay. So now you want to, I'm just rewriting my original problem down. So 6am to the 4th. We're supposed to multiply that by our least common multiple over itself. So 2a squared m to the 4th over 2a squared m to the 4th. And every single thing gets multiplied by that. Okay, so that is going to get me 6am to the 4th times 2a squared m to the 4th. I'm taking every single part and multiplying it by 2a squared m to the 4th. And this time I might show you how we could do a little bit of this work ahead of time instead of having to write everything down again. Okay, so what am I talking about when I was saying over here we cancel out before? Well, let me show you. If there's anything on the top of the fraction that's going to cancel out with anything on the bottom of the fraction, we can take care of that now. So in other words, I've got an m to the 4th here and an m to the 4th there. I could cancel those out. This a right here is a to the 1st, so it can take away one of these a squareds, would leave me with a to the 1st. And then I would know, oh, okay, that's just 12a. Saves me a little bit of work here. A squared can cancel out with a squared. There's nothing else. Oh, 2 can cancel out with 2. So on the top, I'm just m times m to the 4th. Well, that's going to be plus. I'm getting the plus from right here. M times m to the 4th would be m to the 5th. You add exponents when the bases are the same. Okay. I've got an a to the first. That will take out 2 of these a squared, so I would just have an a. I've got an m squared. That's going to take out 2 of these m to the fourth. That's going to leave me with m squared. So now 6 times 2 is 12. A m squared. That would be all that's left up here at the top. And then this a cancels out with one of these a's, which would just leave me a to the first. And that's all I have on the bottom. So the rest of this stuff, 2 times 2 would get me 4. A, so I don't have any more of those. M times m to the fourth would be m to the fifth. Okay, and can we reduce that anymore? Well, on the top, I don't think so. There's nothing that's gonna, the variables are different. This is a 1, so there's not gonna be any numbers I can pull out of that. On the bottom, I can take a 4 out because 4 will go into 12 and 4 will go into 4. I also can pull an a out and I can pull an m squared out because both terms have that in it. Okay, so that's going to be 12 divided by 4, 3. If I take an a out, it's going to get rid of all of those. On this, we would, if we took m to the squared out of m to the fifth, we're just left with m to the third. So we can factor that out. Okay. Let's go ahead and look at this one. This one's very similar to what we start out with. So we've got 2x to the third, an x squared, a 6x, and an x squared. So those are all of my denominators. And we did need to list the x squared again, so we don't have to list that twice. I feel like that this is exactly the same as it is exactly the same as this problem, all right? So we're just going to put C above. It's the exact same problem. There's no sense in that. Let's skip to this one. So we've got 4K, 2, K squared, and K. Okay, so this 4 is really 2 times 2. So we would want to, in our least common multiple, we would want to list both of those. And the biggest K we have is K squared. So that means our least common multiple is going to be 4K squared. Okay. All I'm doing now is just rewriting down the problem that we had. So we've got 2 over 4K minus K over 2, 6 over K squared minus 1 over K. We want to multiply that by our least common multiple over our least common multiple. And we said every single thing gets multiplied by this. Okay, so that's going to give me 2 over 4K times 4K squared minus K over 2 times 4K squared. Over 6 over K squared times 4K squared minus 1 over K times 4k squared. Okay, we're going to try to reduce ahead of time this time. So if we've got anything that's the same on the top and the bottom, they can cancel out. This 4 can cancel out with this 4. This k can remove one of these k squared, so that would just end up with k to the first. So when we look at what we have left, we just have 2k. This 2 will go into 4 2 times. I don't have anything else that can cancel out, so I would end up with 2. K times k squared would be k to the third. On the bottom, the k squareds will cancel out here, so I'm left with 6 times 4, which is 24. K to the first will take away one of these k squared, so I'm left with minus 1 times 4, but we still have a k because we just removed one of them. So minus 4k. Okay, when I'm looking at the top, I can pull 2k out of both of those. That's going to leave me with 1 minus k squared. And on the bottom, we got 24 and 4. We can pull a 4 out of both of those, which is going to be 6 minus k. I'm going quick on this part, but the whole first part of chapter 5 is working on doing things like this. So when you go back and you're doing chapter 5.1, 2, and 3, you're really going to be focusing on factoring. So this is going to come a little bit easier to you when you get here. Okay, last two problems here. We got to find our least common multiple. We've got an x. We've got a y. We've got an x squared and a y squared. So our least common multiple, we wouldn't have any numbers here, but the biggest x I've got is x squared. The biggest y I've got is y squared. So that's going to be what we need to multiply by the top and the bottom, x squared over x squared, y squared over x squared, y squared, because that's going to be our least common multiple. We know when we're multiplying this, we're going to multiply every single thing by that least common multiple. Okay, so that's going to get me 1 over x times, and I'm going to write it at the top so it's not so confusing. Okay, this we're going to cancel out ahead of time. This is just an x to the first, so it's going to take away one of these x squareds. So 1 times this stuff, I would end up with x to the first y squared. One of these y's is going to take away one of these y's, so I've still got y to the first. So 1 times this stuff is going to be x squared y to the first. An x squared gets rid of an x squared, so I've got y squared on the bottom. A y squared gets rid of a y squared, so x squared on the bottom. Okay, so I've got an x and y in both of these top terms. When I take an x out of this, and a y out, I'm just left with y. If I take an x and a y out of this, I'm left with minus x. This is the difference of squares from way back, even in chapter 4, we talked about this. That's y minus x times y plus x. Well, that's going to make these two things cancel out, and we're going to end up with our final answer of x over y. X times y over y plus x. Okay, so this is our last problem we're going to talk about. And look at the denominators on this. We've got an x plus 5 as a denominator and an x minus 6 as a denominator. So when we list those, x plus 5 and x minus 6, well, the least common multiple here, has to be x plus 5 times x minus 6. So that means we're taking out our, rewriting the problem, and we're going to multiply by x plus 5 times x minus 6 over x plus 5 times x minus 6. Okay, just so that we don't have to, well, I'm going to go ahead and stretch it out to make sure I explain it. So 2x plus 4 times all this stuff, well, that's going to be 2x plus 4 times x plus 5 times x minus 6 over x plus 5. On the bottom, we would have our 3x plus 6 times x plus 5 times x minus 6 all over x minus 6. Well, it's kind of easy to see that the x plus 5s are going to cancel out. The x minus 6s are going to cancel out. And so 2x plus 4 over x minus 6, times x minus 6 over 3x plus 6 times x plus 5. So that is the end of 5.4. And like I said, it's a kind of a complicated section. And the next two sections are really pretty easy compared to this one. And we'll be covering both of those on Wednesday. And so that means next Monday, we'll be reviewing for Chapter 5 test. And I'm, depending on how we are doing with that, we'll see. We'll probably go ahead and start our next chapter. But you need to try your hardest to get done with where we are in class. So this week, you should really be wrapping up Chapter 5. I know that the assignments are due a little bit later, but that's the goal, is to stay where we're at in class, because it'll help you do better, not necessarily the assignment dates, because we have to teach we have to give you a little bit of time to get the assignments done. So you're going to do better if you stay where we are in class.